Mr. Harmless here, and we're going to talk about the 45, 45, 90 special right triangle. And it is special. It's unique. What I'm going to show you today only works with a triangle that has 45 degrees, and a 90-degree angle. It only works for this particular type of triangle. That's why we call it for this special right triangle. Now, in this particular shape, the two sides that are next to the right angle are both called legs, and because these are both 45 degrees, this would be an isosceles triangle making these legs the same length. I'm going to put an X here to represent the length of the leg. It could be any particular length. Now, there's a special relationship between the leg. Let's put an X up here. Let me get rid of that little. Don't want you to think there's a minus sign there. Put the X there, and so there's a special relationship between the leg and the hypotenuse. The hypotenuse is definitely longer than the leg. It's not twice as big as the leg. It's less than that, but it's bigger than the same size. So it's got to be some decimal number, like 1.2 times bigger, or 1.3 times bigger, okay? It just so happens that that it's actually the square root of 2 times larger. If you have your calculator and you did the square root of 2, you'd see that the square root of 2 is not exactly 2, right? It's smaller than 2. And so let's clear this out. And let's see your second. Square root of 2 equals, so it's 1.4. And so this hypotenuse is 1.4 times bigger, but not exactly 1.4. It's 1.414213560. And actually this number goes on forever, never ending, never repeating decimal. Okay, so we don't want to write that down. So we can write down the square root of 2, because that's what it is exactly. It's this much larger. And so whatever the leg is, if I take the leg times the square root of 2, that's what the hypotenuse is going to be. So I'm going to write this way, x squared is 2. Now, if you're a formula person, you could have this. You could say the leg is equal to the hypotenuse divided by the square root of 2. Or you could do the hypotenuse equals the leg times the square root of 2. Okay? If you're a formula person, you can do that. For me, I just remember, and sometimes I really love formulas, but for me, I just remember it's the square root of 2 times larger. So if I'm going from the leg to the hypotenuse, I'm going to multiply by the square root of 2. If I'm going from the hypotenuse back to the leg, I divide by the square root of 2. Okay? So that means we can do some problems here, some examples. The first example has this number here. So as I'm thinking through this process, the first thing that I do is identify whether or not it's a 45, 45, 90 special right triangle. I've got a 90, I've got a 45. If I were to subtract those two from 180, I would figure out that this is also 45 degrees. Okay, hopefully you already know how to do that part, but you got to make sure that you can identify the triangle. Once I identify the triangle, I want to identify what number I'm dealing with. Notice the number that I have here is a leg. This x is a leg, and the y is the hypotenuse. So now that you figured this out, then you can figure out what you're supposed to do. If I'm going to find the other leg, it's just the same, right? So this over here equals 8. And so I don't have to do anything. And if there's an easy part of it, just do that first. So the other leg is 8 as well. But now I'm going to try to find the hypotenuse. Now, if you're a formula person, you could say, okay, well, the hypotenuse equals the leg times the square root of 2. Okay. But if you don't want to try to memorize this little formula, or if you're afraid that you're going to forget, is it divide or multiply? Just think about this. The hypotenuse is larger than the leg. So if I have the leg and I'm trying to find the hypotenuse, I know I'm going to multiply. So I'm going to take that leg times the square root of 2 to figure out that hypotenuse. Okay, square root of 2 is always the number that you use with this 45, 45, 90 triangle. So that's the key number. Key number is the square root of 2. Okay, that's for a 45, 45, 90 triangle. So 8 times the square root of 2, we cannot multiply this number with the number on the inside because this technically isn't 2. So it's not like I could have the square root of 16 or something. I'm just going to leave it like this, 8 times the square root of 2. If I did want to multiply this out and get a decimal, I would do 8 times the square root of 2 and on my calculator, and it would end up being a decimal number. For you, let's just leave it. That's easier. 8 square roots of 2. Okay. If you did want to do it, you could do 8 times the square root of 2 equals, and so it's approximately 11.3, I think is what I had. 313. Okay, but you don't have to do this. We can just leave it like this. Now, here we have another one. Now, this is another one. This is the same type of problem as this first one here. Notice that's a 45, 45, 90. The number that I have is a leg. This is also a leg, and this is my hypotenuse. So with this problem, the other leg, right, the legs are equal. So this leg is going to be 25. And the hypotenuse is going to be a leg times the square root of 2, right? We're going to something larger. So I'm going to multiply. The key number is the square root of 2. So I'm going to do a leg times the square root of 2, which is just 25 square roots of 2. Now, this third one, it gives you a different number. It gives you the hypotenuse. This time, we're starting with the hypotenuse. And we need to find a leg, right? Actually, we need to find both of those legs. But it doesn't matter which one I go to find first because they're the same, right? The legs are going to be the same in this 45, 45, 90 triangle. So if you're a formula person, you could say, okay, if I'm trying to find a leg, the leg equals the hypotenuse divided by the square root of 2. If you're just trying to remember what to do, you know the key number is the square root of 2. So you could just say, well, okay, if I'm going from something larger to something smaller, I'm going to be dividing it. And since the key number is the square root of 2, I'm going to divide it by the square root of 2. So I'm going to go 19 divided by the square root of 2. All right, now pause here for a second. We're going to shift gears now out of geometry thinking into algebra thinking, because what we have to do next isn't about the right triangle. This is just about simplifying a number with a radical or a square root in the number. You cannot have a square root in a denominator. Okay, I don't know why. I'm sure there's a really good reason. Some math genius well before my time decided this. But what I know is that I need to get rid of this square root in the denominator. And the only way to get rid of a square root in the denominator is to multiply the numerator and the denominator by that same number, the square root of 2. The reason why this will work has two parts. One, I'm technically multiplying my answer, right? This is my answer right here. I'm technically just multiplying it by 1. Square root of 2 over the square root of 2 has a value of 1. So I'm not changing the answer into something different, but it can change the way it looks. The other reason why this works is because if I do multiply this, right, multiply the numerators, multiply the denominators, the square root of 2 times the square root of 2 is going to be the square root of 4. Since they're both inside of a radical, you can multiply those numbers together. The square root of 4 is then, well, what is the square root of 4? If you do it on your calculator, hopefully you know this one. Square root of 4 is 2. So you learn something. If you multiply a number in a square root times itself, you're going to end up with that number without the square root. And so in this problem right here, we end up with 19 square roots of 2, right? 19 times the square root of 2. Square root of 2 times the square root of 2 is 2. So this x has a value of 19 square roots of 2 all over 2. And since the x and the y are the same, I can put that in here as well. Okay. That's the basics of 45, 45, 90 triangles. And I hope this was helpful. And feel free to watch and share and enjoy these videos. Thank you so much. Bye.